Hello, my name's Ryan, and today I'm going to be showing you all of the necessary factoring methods for algebra. So first we're going to start with GCF, and GCF stands for greatest common factor. So that means we're basically just taking something out, the greatest common factor, from all of the different terms. So let's start with an expression like this. What is the greatest common factor here? So we can see that there's an x in all of our terms. So we can take out an x, leaving us with 3x plus 8. And that's it. Sometimes it's a number, sometimes it's a variable, but this is the starting step for all other methods of factoring, and it's pretty simple. So next, I'll show you factoring by grouping, which is kind of a repeated version of this. So our expression is 3x squared thirds plus x squared plus 6x plus 2. Alright, so we're actually going to separate this into two groups, if we want to call them that. So this group here and this group here. So we're basically going to take out a greatest common factor from both groups. So from the first group, we can see that an x squared is present in both terms, so we're going to take out that, leaving us with 3x plus 1. And then from this side, we can see that a 2 is present in both our terms, leaving us with 3x plus 1 as well. And the key with this method is that this inside here is the same. So it is a little bit difficult if it's not set up to be a grouping. It's not the most common method. But yeah, so the next step is we take these two outside, we add them together, so x squared plus 2, and that's one of our factors. Then our other factor is 3x plus 1. And that is the end result. Next, I'll show you the difference of squares factoring method. So this one is a little bit different because it's not a technique, rather squares. It's more of a formula. So it basically just says this. If we have a squared minus b squared, right? Difference of two squares. This is a square, this is a square, this is a difference. This is equal to a plus b, a minus b. So let's say we have an expression like this. Right? The first thing we should look for is always the greatest common factor. And there is one here. 81 is divisible by 9, as well as 9 is obviously divisible by 9. So 81 divided by 9 is 9, leaving us with the x squared there, minus 1. And then we see that there's two terms here. This is a squared term, 9 and x squared are both squares. And then 1's also a square. So we can apply this formula. So let's say our a is equal to 3x, because 3x, all of that squared, 3 squared is 9, x squared is x squared, and then b would equal to 1. So let's apply this formula, 3x plus 1, 3x minus 1. And always, don't forget that 9 up front. So this is fully factored. If we decided to skip the greatest common factor, and we said a was 9x, and then b was 3, we would be left with 9x plus 3, 9x minus 3. But there's still a GCF in there, so this is not fully factored. So that's why we have to always look for a GCF in the front. Next, I'll show you how to factor basic quadratic trinomials. Let's start with the trinomial x squared plus 6x minus 16. So how this works is we're actually it's kind of a guess and check method. So we're gonna need two numbers that add to the middle term, 6, and multiply to the end term, 16, or negative 16. So it's kind of a guess and check. Well, when I think of 16, I think of 4 and 4. But it's negative 16, so it'd be negative 4 and 4. If we plug those in, negative 4 plus negative 4 plus 4 is 0, not 16. So that doesn't work. Let's try 8 and 2. I know 8 and 2 is 16, but if it's negative, we have to make one of them negative. So let's try 8 and negative 2. Negative 2. 8 and negative 2. So we know it equals negative 16, but that also works too. So now what we do, we have our two numbers that work. We're going to rewrite them kind of like this. So we're going to have a plus, and then we're going to add, our two factors are going to be x plus one of the numbers, and then plus the other number, x plus -2. So now we can also check our work by saying we can add together. We can use the FOIL method. So first, x times x is x squared. Inside, 8x. The outside, minus 2x. And then the last term, -16. And so these combined together make 6x, leaving us with x squared plus 6x minus 16. And for all factoring methods, it's best to check your work if you're unsure by using foiling and multiplying out all the terms. Next, I will show you what to do if that first term isn't equal to 1. So let's take the expression 3x squared minus 32x plus 20. So now we could try to do that same method, but that would be like we're factoring x squared minus 32x plus 20, because we didn't consider that first number, that 3, because that last method assumes that that is a 1. So now we have to do a little workaround. So all we have to do, this is called the split the middle method. We have to multiply these two terms. So 3 times 20 is 60. So now when we're doing our multiplication, we have two numbers. They still add to the middle term, -32, but now they multiply to the product of the first and last, so 60. So our two numbers, well, I think of 4 and 15. That doesn't work because 4 and 15 don't add to -32. Also, we see that this is a negative, and two negatives equal a positive. So this is going to have to be a negative plus a negative, and then so both numbers are going to be negative. So 20 and 3 is 60. Not quite. Doesn't really work. Let's try that. 20 and 3, -20, -3. They add to -23. But 30 and 2, those do work. -30 here and -2, those add to -32, and -30 times -2 is 60. So now what we actually have to do is the split the middle part. So we are actually going to set up a factoring by grouping. So we're going to split the middle by saying that 32x is now going to be broken up into -30x and -2x. And then we'll leave the last term the same. And then now we just have to do factoring by grouping. So our first group here, 3x squared minus 30x, we have a 3 as our common denominator, and then an x for the variables. So leaving us with an x there, and then minus 10. And then we can bring out a -2 here, leaving us again with x minus 10. And then we'll do the same process where we put this term and this term together, multiply that by whatever's on the inside. All right, leaving us with 3x minus 2 and x minus 10. Perfect. Now, I will show you a much faster method, I feel like, for those. It kind of combines those last two methods. I call it the x method. So let's take the polynomial 24x squared plus 7x minus 5. So what we're going to want to do is same thing. We're going to be guessing and checking and finding two numbers, but this time we're going to do it in a different fashion. So these two numbers here that we place are going to multiply to 24. Let's say they're 6 and 4. These two numbers are going to multiply to -5. Say -5 and 1. And then we're going to draw an x between them. These two numbers, we're also going to want to put an x there because 6x times 4x equals 24x squared. Then we're going to go multiply like an x, cross multiply kind of thing. 6x times -5 is -30x. 4x times 1 is 4x. And now these terms want to equal that 7x. They do not equal. So now we'll try again. We might be able to try, we know that 5 and 1 are the only factors, so the only thing we can do is change the negative sign. On this side, maybe we'll try flipping those two places. So put the 4x on top and the 6x on bottom. We end up with -20x and 6x. that would equal negative 14. That's not quite what we're looking for. Let's try 3 and 8. 3x and 8x. 3 times 5, negative 15x. 8x times 1, 8x. Now we can see, we know 15 and 8 are 7, and we add these up, we get negative 7x. So now look, we're pretty close. All we need to do is change around the negative sign. We can move this negative sign up here, now giving us negative 8x and positive 15x, giving us positive 7x. So now, you might be wondering what we do with those numbers we just found. We just go straight across to make our factors. So the first factor is 3x minus 1. The other is 8x minus 5. I think this is a little bit faster than the split the middle method, and it can also work for the basic trinomial method as another way to represent it. So we can just, if we took that basic trinomial we had before, x squared plus 6x plus minus 16, we can do the same thing, except for these two terms are always going to be 1x, because we always have an x squared as the first term. Let's draw our x. Then now we're just looking for those two numbers again. I like to use this x method for all forms of trinomial factoring like this, because it's a little bit more, it kind of just puts it all into one thing rather than having to remember two different methods, and it kind of helps my brain recognize the thing I'm doing. All right, next I'm going to show you perfect square trinomial factoring. So perfect square trinomial is similar to difference of cubes, where it's more of just a formula rather than a method. So I'll show you. So a perfect square trinomial would look something like this. A plus b squared, and that's going to equal a squared plus 2ab plus b squared. Let's take a look at one of those trinomials. So say we had the trinomial x squared plus 14x plus 49. So now we can see those two n terms, x squared and 49, are both perfect squares, right? X times x and 7 times 7. And then when we add them together, or we multiply them together, 7 times x is 7x. We multiply that by 2 following our formula, we get 14x. So now we know that this is indeed a perfect square trinomial. We can use the formula a plus b squared. So a is equal to x, b is equal to 7, so we have x plus 7 squared. And that is the factor form of this, or that is basically written as x plus 7 times x plus 7. And if you didn't remember this formula, you could use one of the other two factoring methods. Then you'd realize both the numbers are 7. You'd write it like this, and then you could correct it to x plus 7 squared. The last factoring method I'll show you is the sum of cubes method. And it's also a formula, kind of like difference of squares or perfect square trinomial, and it's going to look something like this. So a to the third power is a cube, plus b to the third power, which is also a cube, factored is equal to a plus b times a squared minus ab plus b squared. Now the same thing is true of a to the third power minus b to the third power, but this is slightly different. A minus b, then a squared plus ab plus b squared. And there's a cool acronym you can use to remember the signs for these, and we call it SOAP. And that basically stands for same, opposite, always positive. So same sign here, opposite sign, then this one's always positive. Same sign, opposite sign, always positive. So let's try this. If we had something like 8x to the third power minus 27, we'd have to apply our difference of cubes formula. So we have to identify first our a and our b. So let's say our a is equal to 2x, because 2 to the third power is 8, x to the third power is x third. And then b is equal to 3, because 27 is 3 squared, 3 cubed. So, for our first term, we're looking for same. So same sign as minus. So that means we're going to have a minus between 2x and 3. Then we're going to square that first term, that a squared, 4x squared. Then opposite, so that was a minus, so we're going to make it a plus. And then we're going to multiply those two together. So 2x times 3 is 6x. Then finally, always positive, leaving us with the b squared, which is 3 squared, which is 9. And then that is the fully factored form of 8x to the third power minus 27. That's all I've got for you today. These factoring methods are really useful, and you're probably going to want to know almost all of them because they're going to come up, even if you don't know, if you know them well now, they're going to come up later, and it'll help you out later. Thanks for watching.